Okay, today we're recording this class because we're experiencing technical difficulties. Anyway, if you look at the board, we're coming to the end of the quarter. There's only 7 days of school, right? Because next week, Thursday is class day and Friday is a holiday, right? Yeah, Friday's a holiday. I believe, yeah. Anyway, so there's only reserved days left. So the only reserved days for math are next week, Monday and Wednesday. So there's going to be a quiz on Monday. It might be a maxi quiz though, for you guys. And then the test is Wednesday. This chapter is not that long. This is all review from last year. It's about functions. A maxi quiz is a quiz that's worth 30 to 40 points. An ultra maxi quiz would be a quiz worth 50 to 60 points. I don't know, like maybe we need an ultra maxi quiz on Monday. Whatever. Okay, so today we have to learn about functions. Well, you guys already learned about functions, right? This is review. I'm going to stress everything in this chapter is review. Everything. I don't think there's anything I'm going to teach you that's new. You guys just probably forgot everything. Okay, so first of all, you guys got to know these 3 terms. Relation, function, one-to-one function. What? Okay, let me draw a graph for you. Ooh. Wow. Is this a relation? Well, first of all, you got to know what a relation is. Look at the definition in your notes. A relation is simply a set of ordered pairs. Basically, any graph you draw is a relation. So is this a relation? Yes, it's a relation. Now, is this a function though? Now, what is a function? A function is a relation where for every x value, there's at most only one y value, right? So you guys probably learned the vertical line test. Does that sound familiar? Every vertical line you draw can intersect the graph at most once. So is this a function? Yes, this is a function. Is this a one-to-one function? A one-to-one function has to pass both the vertical and the horizontal line test. So is this a one-to-one function? No, because if I draw a horizontal line here, it intersects it more than one time, right? So this would just be a relation and a function. It's not a one-to-one function. Whereas, what if you had a graph that looked like this? Like, for example, y equal x cubed. Is this a relation? Yes, any graph is a relation. Is this a function? Yes, because it passes the vertical line test. Is this a one-to-one function? Yes, because every horizontal line you draw intersects the graph at most once. So this is all 3, a relation, a function, and a one-to-one function. Okay, so here's some terms that you need to know. Even and odd. What is the definition of an even function? F of negative x equals f of x. In other words, if you plug in negative x for x into the function, you will get the same thing you started with. Okay, example. F of x is equal to x squared. Ah! Let's go x to the 4. No! 6 then. Is this an odd even function? Well, if you plug in negative x for x, simplify that. You get x to the 6. Is that the same as the original function? Yeah, so it's even. And can you see why they call it an even function? Because if you put any even number there, you plug in negative x for x, you get the same thing, right? Anyway, what do we know about even functions? If I graph them, they will be symmetric about the y-axis, right? Like y equal x squared. Even functions are symmetric about the y-axis. What's the definition of an odd function? F of negative x equals negative f of x. If you plug in negative x for x, you get the opposite of the original function. For example, f of x equal x to the 5th. So the first thing you do is you plug in negative x for x, like that. Simplify it. What does that come up with? Negative x to the 5th. Is that the same as the original function? No. Is it the opposite? Yeah. So therefore, this is an odd function. I wonder why they call it odd. right? Because if you put any odd power there, like 1, 3, 5, 7, right, you're going to get the opposite of what you started with. And odd functions are symmetric about the origin, like y equal x cubed. Woo! You guys know what it means? See, this has symmetry about a line, but this one is symmetric about a point, right? 180-degree rotational symmetry. I think that's the way you guys learned it in geometry. Okay, so number 1 of tonight's homework, I'm going to give you a function. You have to determine whether it's odd, even, or neither. Okay, let me give you an example. F of x, this is probably the same as the example in your example problem. X to the 4th over x, no! X cubed over x to the 4th plus 1. Even, odd, or neither. Now hopefully you can do this in your head. But if you cannot, just do this. Plug in negative x for x. Wherever you see x, plug in negative x. And then simplify that. What is negative x quantity cubed? And then who did that? And then you ask yourself, is that the same as the original function? No. Is it the opposite? Yeah, because it's got the minus sign there, right? So this is an odd function. That's it. Okay, next you have to be able to determine domain and range. Now, if you have the graph right in front of your face, it's easy to figure out domain and range, right? Okay, let's do an ellipse. Woo! Okay, here's the center of the ellipse, 2, 1. Let's say this point is negative 3, 1, and this is 7, 1, and this is the point, this is the endpoints of the minor axis, 2, negative 2, and this is the point 2, 4. Right? You guys remember drawing ellipses last year? Is this a function? No, because it doesn't pass the vertical line test. So someone will be going, yeah, no. If you draw a vertical line that intersects it more than once, it's not a function. Is it a relation? Yes, anything you draw is a relation. Okay, now what is the domain of this? The domain is a listing of all the x coordinates on a graph. So what's the smallest x coordinate? Negative 3. What's the biggest? And is there everything in between? Yeah, so the domain is simply going to be x such that negative 3 is less than or equal to x less than or equal to 7. And by definition, domain is a set, so you have to have a set. This is correct set notation. Or if you rather write interval notation, you can do this because that's a set already. Interval notation is a set. Okay, what about the range? A range is a listing of all the y coordinates on a graph. Well, what's the smallest y coordinate on the graph? Down here. Negative 2. What's the biggest? 4. And is there everything in between? Yeah, so the range would be from negative 2 to 4, or if you rather write it like that, it doesn't matter to me. So if you have the graph in front of your face, it's easy to figure out domain and range. But we have to be able to figure out domain and range without the graph. I mean, I guess you could just draw the graph and look at it, but sometimes that takes too long, especially knowing your graphic skills, right? So f of x equals x plus 2 over x minus 3. Without drawing this graph, what is the domain? In other words, what numbers can I plug in for x? Or can I not plug in for x? What's the only number I cannot plug in for x? 3, because it makes the denominator 0, right? So the domain is simply x such that x cannot equal to 3. Or if you rather write it like this, right? Anything but 3. So it's easy. Whenever you have a fraction, you just got to make sure the denominator cannot be 0, right? We've been taught that since Algebra 1. Okay, now how about the range? How do you find the range of this critter? Well, now f of x is like y, right? Now look at the procedure for finding domain. Notice that y is solved for it, so you solve for y, and then you just look for restrictions on x. So if I want to find range, what do you think I'm going to do? Look, in the domain, you solve for y. So range, you're going to solve for x. That's right. So you take this equation, and then you solve for x. How would you solve for x? What do I do? I need to, okay, what if you're in a Turkish prison? The only way you're going to get out of that prison, you better solve for x. You're just going to wallow in there the rest of your life. Okay, no, let's wallow. Pretty boring, you know. How do you solve for x? Somebody do something. It rhymes with Haas multiply. You cross multiply. Oh, well, Mr. Park, there are two terms of x. So you bring all the x's on one side. This is just algebra 1, man. Factor out the x. And then divide it. So you get 3y plus 2 over y minus 1. There, that's how you solve for x. And then now you look for restrictions on what y can be. Well, I see a fraction. I just got to make sure the denominator is not 0. So y can be any number except 1, because that makes the denominator 0. So the range is any number except 1. Isn't that pretty easy? It's very mechanical. Just like the last test. Something went wrong with the mechanics. Woo! Okay, so that's like an easy problem. Okay, let's kick it up a notch. F of x is equal to the square root of x plus 1 over x minus 2. How do you find the domain of this? Mr. Park, I don't even know what this graph looks like. Well, you don't need to know what the graph looks like. If you have a square root function, the inside has to be not just positive, but it could be 0 too, right? Because the square, you get square root 0, right? Square root of 0 is 0. So whenever you have a square root, the inside has to be greater than or equal to 0. Okay? And then if you solve that inequality, that's your answer. Do we know how to solve inequalities? Yes, we just took a test on it. You make one side 0, which it is. You factor the side, which it is. So now we are ready for the number line. What goes on the number line? Negative 1, come on, you guys should be expert at this. Negative 1 is included, but 2 is not, right? How come? I'm not going to even ask that question, that's just dumb. And then how do I know it's plus minus plus? Okay. And then we're looking for greater than or equal to 0, so it's here, and then it's there. So your domain will be from negative infinity to negative 1, and then from 2 to infinity, but not including 2. That's why it's so important to solve inequalities. Well, this is one reason why. That's probably not the most important. Okay. Okay, now let's kick it up a notch. Okay, I'll leave that on for a little while. Y equals 2x squared minus 8x plus 5. Find the range of this. Okay, Mr. Park, you told me that to find range, I have to solve for x. Okay, now, how would you solve for x if there's an x squared and an x term? How do you solve for x? Like, if you didn't have the x squared term, easy, right? Or if it didn't have this x term, that's easy too. But if you have an x squared term and an x term in there, how the heck do you solve for x? Try. Okay, either complete the square or use the quadratic formula. That's right. So what you have to do is make one side 0 and put it in quadratic form. Okay, so what's the coefficient of x squared? No. 2. What's the coefficient of x? And then what's everything else? 5 minus y. You got to bring this y on this side, yeah? Now once you put it in quadratic form, you simply use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, Mr. Park, this is a lot of work. Yeah, but that's what you got to do sometimes. And then now what? Well, whenever you see a square root, the inside has to be greater than or equal to 0. So the inside, let's start simplifying. Inside is 64 minus 40 plus 4y has to be, did I do that correctly? No, that's 8, monkey! Did I do that correctly now? Yeah, so the inside of the radical got to be greater than or equal to 0. So if you solve this, that's going to tell you the range. So 8y is greater than or equal to, okay, this is 24 on this side. If you move it on this side, negative 24. We're going to play that game again. negative 3. Oh, there you go. So if you're going to write it like that, though, you got to make a set now. Because domain and ranges are sets. Oh, that's not that hard. Yeah, it's not that hard. However, sometimes there's an easier way. Because Mr. Park, that's kind of a lot of work, and I don't like using the quadratic formula. Is there something better I could have done? Yeah, this is a well-known graph. This is a, rhymes with parabola. It's a parabola. How do I know it's opening up? Yeah, duh, that's why. And if I want to figure out the range, what? Don't I just gotta compute the vertex? Because if I know the vertex, the range is easy, right? Do we know how to find the vertex of a parabola? Yes, negative b over 2a. We still gotta know that? You don't have to know anything, just do this all the time then. I think negative b over 2a is a lot simpler. So, negative b over 2a. Oh, that's 2. How do I figure out the y-coordinate? You plug it back in. So if I plug in 2, you get 8 minus 16 plus 5. Negative 3. So what's the smallest y-coordinate on this graph? Negative 3, and then everything above. So isn't the range going to be negative 3 to infinity? Which is the same thing as that? Which way was faster? Yeah, but then see this, you can do this because it's a graph we know, but sometimes you don't know what the graph is, so sometimes you just have to use the quadratic formula to solve for that. Because there's going to be several in your homework tonight. Okay, next. What's next on the list? I think it's absolute values. Okay, I'm going to do a problem that's almost exactly like your homework, okay? So if anybody writes this on the board tomorrow, in fact, I think I did an example like this too. Okay? Anytime you see an absolute value in a function, automatically you should be thinking this is a piecewise function. Okay, so you just do that automatically. Now let's review what absolute value of x is, right? Absolute value of x is a piecewise function. If the inside is positive, you leave it alone. If the inside is negative, you negate it. Oh, you heard that? Okay, so if I'm going to make a piecewise function, okay, so here's the absolute value. What number do I put? 2. How come 2? Over here it says 0. That's because 0 makes the inside 0. That's why. Over here, what makes the inside 0? 2, right? Because on one side of 2, it's going to make it positive. On the other side of 2, it's going to make it negative. Mr. Park, over here, got an or equal to sign. How come don't have it on this one? Because it makes the denominator 0. You cannot have a denominator being 0. Okay, so remember how absolute value works. If the inside is positive, you leave it alone. If the inside is negative, you negate it. So if the inside is positive, we're going to leave it alone. So you're going to use this one. X squared minus 4 over x minus 2. If x is less than 2, that means the inside will be negative. You're going to negate it. So you use this one. And there you go. That's your piecewise function. That's why we learned all that stuff last chapter, so you can use it this chapter. If the inside is positive, leave it alone. If the inside is negative, you negate it. Oh, Mr. Park, you can simplify this though. How do you simplify this? Yeah, because you can factor the top as x plus 2 times x minus 2. So can't I cancel this and this? Yeah, and so what's left? X plus 2. Hey, that's a line. Yeah. And what about this one? If I factor it as x plus 2 times x minus 2, this and that cancel. So you get negative x plus 2. Oh, there you go. That's your piecewise function. Okay, now you got to graph it. Did you guys learn how to graph piecewise functions last year? Okay, this is the way you can do it. Okay, do we know how to graph the line y equal x plus 2? Yeah, it looks like this. But we're only going to graph it when x is greater than 2. So here's 2. So we're only going to graph it from here to the right. You don't graph the whole graph. You only graph over the specified domain. Yeah? Okay, so you can do that, but when you're an expert, you don't want to do that. This is what I do. Okay, so x is less than 2, so 2 is the key point. Plug in 2 here, what do you get? If you cannot plug in 2, you know how sad that is? 2 plus 2 is 4 with a negative sign in it, but it's negative 4. So you plot the point 2, negative 4, and since this is a line, what's the slope of this line? If you distribute the minus sign, what's the slope? Negative 1, just oh. Or if you have to graph the whole line, and then go, okay, I'm only going to graph it when x is less than 2, so starting from here and then to the left. If you have to do that then. Whatever, but you got to get that. Now, did you guys learn how to graph piecewise functions on your calculator last year? Another class said no. Okay, I'm going to teach you. Take out your calculator. Now, of course, in real life, if you're going to graph this on your calculator, then just punch it in right here. Okay, but we're going to do this one because I want to teach you how to graph piecewise functions. Okay, will this work? Can I just do this? y1 equal x plus 2, and then y2 equal negative x plus 2. Is that going to work? No, because here, this is what your calculator is going to do. It's going to graph y equal x plus 2, woo! And then now it's going to graph y equal negative vector, woo! Is that the same thing as this? No, because you got to tell your calculator how to restrict the domain. The other class didn't know, so I just tell you. This is how you restrict the domains. You take whatever graph you're doing, and then you divide that by x is greater than 2. And then this one you divide it by x is less than 2. Okay, now of course the next question is, where do you get the greater than and less than signs? Well, in a TI calculator, it's under test. You guys see the test? Second math. It's above the math button. Now, for those of you with the prism, they couldn't figure it out. You found it? No. Options? Maybe? Or, I know, Colby said it's in the catalog. Of course, catalog has everything in there, right? If you don't know where something is, just go to the catalog. There must be a faster way of getting it on the prism, though. So now, why don't we do a zoom decimal? Do a zoom 4. You should see something like this. So what happens is the graph goes, so it goes like this, and then, now do you guys understand why this works? You guys probably don't, yeah? Let me explain to you how a graphic calculator works. When a graphic calculator graphs, if you're in zoom decimal, it goes from negative 4.7 to 4.7 on the x, okay? So what happens is, it starts at negative 4.7, it plugs it into your function, and it plots the point. Then it goes to negative 4.6, it plots a point, and it connects it with the line. Then negative 4.5, so every time it plots a point, it connects it with a line, so it's like this. Until you get the whole graph. So basically, your calculator just sweeps from left to right. It goes from negative 4.7 to 4.7 in increments of 0.1, if you're in zoom decimal. Okay, now, what the heck is this? Well, when you do this, when you divide by this, if this is true, the calculator returns a value of 1. If this thing is false, it returns a value of 0. So, if you're at negative 4.7, is negative 4.7 greater than 2? Do we really have to think about that one? No, it's not. It's false. So what happens, it returns a value of 0. So it tries to plot the point, negative 4.7, and this divided by 0, which is undefined. Right? So at negative 4.7, there's no point to plot because it's undefined. So there's nothing. Okay, then you hit 2. Okay, 2 is not greater than 2, so it's still nothing. But when you hit 2.1, now it's true. So what's going to happen? It's going to graph this divided by 1, which is simply the graph of that, and that's why it works. You get it? So when this is false, it graphs this divided by 0, which is undefined, which is no graph. But if this is true, it graphs this divided by 1, which is just that graph that you want. And that's how a graphic calculator graphs. Okay, so I think on your homework tonight, there's like an A, B, C problem. This looks exactly, almost exactly. I think tonight was this, with a 1. So actually, the one I just did is harder. Nobody better put this on the board tomorrow. Plus, I think it's in the examples as well. Okay, the other one of them you might have a trouble with it because it's like two parabolas. See, this is just two lines. The other one is two parabolas. Okay, and then the last thing I have to teach you, I just want to make sure I go over everything. Yes, is the difference quotient. Does this look familiar from last year? This book, your book last year had a lot of problems like this. This is called the difference quotient. Well, it's a difference quotient, but it's the difference quotient. The reason why this is so important, and the reason why it's in every Algebra 2 and pre-calculus textbook, is because all of calculus is based on this expression right here. Ready? Does this look familiar at all? Ano do these words sound familiar? Difference quotient. Chai. Oh. Just stop right there. Okay, so what's going to happen is I'm going to give you a function. Guaranteed, well, parents, this is going to be on the quiz. Okay? I'm going to give you a function like this. You have to be able to form this difference quotient. Okay, let's do it. If you break it up into pieces, it's a lot easier. So here, do this one first. How do you compute f of x plus h? If this is f of x. Yeah, it's x plus h cubed. You just take whatever's in the parentheses and you plug it in for x. Just like if I were to ask you, what is f of 2? Don't you take 2 and plug it in for x? Yeah, so f of gorilla, you plug in gorilla in for x, right? It doesn't matter what it is. Here, f of gorilla. All you gotta do is plug gorilla in for x, so you get gorilla cubed. Oh, now I get it. Minus f of x. F of x is the given function. And then you divide the whole critter by h. There you go. That's called forming the difference quotient. So on the quiz, or tonight's homework, whatever, all I'm going to do is change this function. Like I remember on previous quizzes, I give things like this. 3x squared plus 4x plus 5. I give it 1 over x, 1 over x squared. What else did I give before? X to the 4, x to the 5th. And since I told you that, now I'm going to give x to the 6th. Okay, and so I'm pretty sure you can form this difference quotient. Now you got to simplify it. How do you simplify this? Simplify. You got to expand this, people. And what did we just learn last chapter? The binomial theorem. That's why I can give you any power there. You should be able to expand it because we just learned the binomial theorem. So expand this. Go. 3 choose 0, x to the 3rd, plus 3 choose 1. The powers of x go down by 1. The powers of h go up by 1. 3 choose 2. The power of x goes down by 1. The power of h goes up by 1. And then 3 choose 3, which is 1, and then h cubed, right? You guys remember the binomial theorem, right? See? The powers of x go down by 1, down by 1, down by 1. The powers of h go up by 1. That's the binomial theorem. That's so stupid. Okay, so you expand this, and then you subtract x cubed, and then you divide the whole critter by h. And if you remember these problems from last year, these all simplify pretty nicely. Yes, they do. This x squared cancels, x cubed cancels the x cubed. Can I factor out an h on the top? And cancel it with the h on the bottom? You bet your sweet 50 you can. So like boonga boonga. So your final answer is 3x squared plus 3xh plus h squared. There's a reason why people put things in books and why teachers teach you things, because all of calculus is based on this. You have right now you have no idea how important this formula is. You just have no idea. You want me to explain like the other class? But then we kind of ran out of time. That's it, I'm explaining it since we're on video. So suppose you have any function. It doesn't matter what it is. Suppose you're at this point x right here. What are the coordinates of this point? X, comma, y. But what is y equal to? F of x. Okay, now, what if I were to move h units to the right? Where would I be? X plus h, right? If you're at x and you walk h units to the right, aren't you at x plus h? Wait, let me try. Yeah. What are the coordinates of this point then going to be? X plus h, comma, half of x plus h. So this difference quotient here simply gives you the slope of the line going through those 2 points. We call this a secant line. How do you find the slope of this line right there? How do you find the slope of any line? Y minus y over x minus x. So y minus y all over x minus x. What is that minus that? H. Oh, there you go. That's the difference quotient. That's why it's in. I can't believe you guys don't remember. Every year they say, yeah, they remember this. But this is the first year. No, I don't remember. And I think in your book last year, they gave it to you like over and over and over again. Okay, so tonight's homework, I don't know, maybe I did give you x cubed on tonight's homework. Who has the homework up? Where's the difference quotient? Oh, you guys have x to the nth power. Just use the binomial theorem. Okay, and then also, wait, one more thing. I saw one more thing on the homework. Oh, okay, here we go. You have to be able to graph things that are not functions on your calculator. So here, something like this. 2x squared plus 3xy plus y squared. No! 5y squared equals, give me a single digit number. 7. Graph this on your calculator. Now, without this xy term, what did we learn last year? What is this graph going to be? Oh, come on, this is last algebra 2, people. It rhymes with ellipse. Ellipse! It's an ellipse. Come on, I know Mr. Tucky used to taught you this, but once you put this xy term in, what does that xy term do? Okay, last year, what kind of ellipses did you draw? You did like the major axis is horizontal or vertical, right? This xy term tilts it, so you get ellipses that are tilted. Now, how do you graph this on your calculator? Well, on your calculator, it can only graph when it's y equal, right? You have to solve for y. So what you have to do is you have to solve for y. But how do I do that, Mr. Park? I see a y squared term and then a y term. Quadratic formula. So you have to put it in quadratic form like this. Something y squared plus something y plus something equals 0. Okay, here's the y squared term. What's the coefficient? Okay, here's the y term. What's the coefficient? And then here's the other stuff. So that's 2x squared, bring it over, minus 7. So once you put it into quadratic form, just use the quadratic formula. Y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That sounds like the dumb owl. The Donald Duck. 3 pi equal 3.1415. Whatever. Then of course you guys can simplify this, yeah? Here, let's practice right now. How much time? Oh my goodness. So negative 3x plus or minus the square root. Okay, this is 9x squared. Do this quickly. Minus 20 times 40x squared plus 20 times 7. Did I do something wrong? 20 times 2. That's right. 20. What is 20 times 7? 140. So it's 140 minus 31x squared. Ooh, that's ugly. All over 10. So how the heck do I do this on my calculator? Well, you do 1 with the plus and 1 with the minus. So this is what you punch it on your calculator. Do this. y1 equals negative 3x plus the square root of 140 minus 31x squared divided by 10. And the other one's going to be negative 3x minus the square root of 140 minus 31x squared divided by 10. So what happens is this one will graph the upper half of whatever the graph is. This one graphs the lower half. You put them together and you get the whole graph. Because your calculator right now only can graph functions. So that's why you have to solve for y. Because right now that's the only thing you can do. Okay, try it. Then let's try a zoom decimal. And my guess it's going to be a tilted ellipse. I just made up these numbers, but that's my guess. It's not really a guess. I know what it's going to be. So that's what you're going to have to do at tonight's homework. Oh, I even have an example in there. Look, difference quotient. Oh, did you get it?
No.
Oh, gosh. Oh. What kind of window do you have? Negative 10 to 10 and negative 15 to 14. TI people, do a zoom decimal. I love zoom decimal because that's the way the graph looks. That's why. You prism people, you just. Oh, there you go. That's beautiful. Tilted ellipse. Yeah, but Mr. Park, how come my ellipse, the thing is kind of like this? How come the thing not filled in over here? That's because I told you. Oh my gosh, look at the time. When your graph draws, it plots a point, then the next point, then connects it with the line, yeah, like this. That's how your calculator goes. What happens if the point right before this one is undefined? Like what happens when you get the square root of a negative number? Then that's why you're going to have like a gap there. That's why there's a gap, because the point right before that one was undefined. So how can it connect it with the line when there's no point? You know what I'm talking about? But you got to know better. You got to know that this is an ellipse, so you got to mentally fill it in. Don't get a Sharpie and fill it in like that. So you wouldn't scream. Okay, you only got 3 minutes left. I got to show you the test. Ah! Okay, I guess you just have time to look at